Hi guys, today we're going to talk about dividing radicals, a second part of it, which is when our denominator is going to be a binomial denominator that needs to be rationalized. So for example, if you have 6 over the square root of 5 minus the square root of 2. So now your denominator is a binomial and you have an irrational denominator. So what you're going to do is, to rationalize a denominator that looks like this, is you are going to multiply by the conjugate. So if you remember, I've used this term just a couple of times. The conjugate of radical 5 minus radical 2 is radical 5 plus radical 2. So you wouldn't say it's opposite, because both terms are not the opposite sign, only the middle sign changes. Okay? So when you multiply two conjugates, you're going to end up always with a rational number. Okay? So you'll see, I'll do it on this example. So on 6 over radical 5 minus radical 2, if I multiply by radical 5 plus radical 2 over radical 5 plus radical 2, remember, I'm really multiplying by what number? I'm multiplying by 1. That's what lets me do this. In the denominator, what's going to happen is, if you FOIL, first times first is going to give us radical 5 times radical 5 is 5, right? Square root of 25. Now, if you multiply outsides and insides, right, it's really like you're multiplying a plus b times a minus b. What do you get when you multiply a plus b times a minus b? You get a squared minus b squared. The middle terms cancel out. So on the outsides, I'm going to get radical 10. And on the insides, I'll get negative radical 10. They cancel out. So I'm not even going to write that step, or those two steps. Instead, I'll go right to the second part squared, the b squared. So negative radical 2 times radical 2 is minus 2. So you end up with a denominator of just 3, 5 minus 2. And that's always going to happen, because you're multiplying the conjugates. You're multiplying a plus b times a minus b, which will always result in a squared minus b squared. And you could skip multiplying outsides and insides. So in the numerator, I have to distribute the 6 in. So I'll distribute the 6 to radical 5 plus radical 2, and I end up with 6 radical 5 plus 6 radical 2. Now, those are unlike terms. I can't add them, but I can simplify this, because I have the rational numbers all have a common factor. 3 goes into itself once, it goes into 6 twice, and it goes into 6 twice. So my final answer is 2 radical 5 plus 2 radical 2 over 1. I don't need to write over 1. That's my final answer. Okay, so we'll take a look at another one. Take a look at example 2. 18 over 1 plus radical 5. So feel free, guys, to pause the video and try this one on your own. Okay, I'm going to multiply numerator and denominator by 1 minus radical 5. 1 minus radical 5. So when I multiply the denominator, I'm going to have 1 times 1, which is 1, and then I'm going to skip just to the lasts. Radical 5 times radical 5, I'm going to get minus 5. In my numerator, I'll distribute the 18. I have 18 minus 18 radical 5. So I now have 18 minus 18 radical 5 all over negative 4. There's a common factor with the rational numbers. These all contain a factor of 2. So 2, 9, and 9. So my final answer is 9 minus 9 radical 5 over negative 2. Or, and you're going to see this on the answer key for one of the problems, we don't really like to leave the negative, a denominator that's negative. It's okay if you do, but it's kind of like not nice. So what we do is we move the negative up. But when you move it up, it distributes. So it becomes negative 9 plus 9 radical 5 over positive 2. So if you remember, when you have a fraction that's negative, right, let's say if you had 1/2. If 1/2 is negative, the negative could be with the 1, or it could be with the 2, or sometimes people just write it in the middle. But really, it's either with the numerator or the denominator, because a positive divided by a negative creates a negative quotient, right? So in this example, when I move the negative up, though, it's a binomial, and there's always parentheses around that binomial. So that negative distributes in. Okay, and then we kind of prefer this one, but I put both on the answer key for you so you can check. All right, so these are pretty simple. So you're going to work on these tonight. You're going to work on pretty much finishing lesson 5, except for I had you skip over the cube root problems. Like I said the other day, we're not going to be learning cube roots. We're going to just stick to the square roots. All right, have a wonderful weekend. Bye.